problem is I know we can get the values here, but you'll see quite soon that the values don't actually work out nice when I graph it on this scale. So what is tan of 0? 0. What's tan of pi over 4? 1. What's tan of pi over 2? This is the undefined. Remember the y-axis, the 90 and the 270 is undefined, and the 0 and the 180 is 0. Tan of 3 pi over 4. I'm sorry? Negative 1? Tan of pi, 0. Tan of 5 pi over 4. 1, yeah, because that's the quadrant tan's positive in, right? Tan of 3 pi over 2, undefined. Tan of 7 pi over 4, negative 1, and tan of 2 pi, 0. Okay, so if we start plotting it just like it is, if you go at pi over 4, which is the middle one, it's at 1. The problem is it curves up too high, and it might be hard to see the asymptote. We'll see. But at pi over 2, that's the undefined, so that is my vertical asymptote. At the next undefined is 3 pi over 2. Do you see that? So at pi over 2 and negative 3 pi over 2, we're going to have the vertical asymptotes. And if I look, we didn't do any of the negatives, but let's just do this for fun. What is tan of negative pi over 4? That would be the same thing as what? Tan of 7 pi over 4. So that would be negative 1. So do you see, if that's the case, do you see this part of the graph up here in my TA84? It looks like this, but my problem is it's hard to curve it up and hit this asymptote. So they're very lenient on how you graph your tan graph. You have to have the asymptotes in the right spot and the zeros in the right spot and the positive and the negatives in the right spot. But the actual kind of gist of the graph is more about the shape. So for instance, to hit this and get it up to the asymptote would probably bring you way up here. So we kind of just it's kind of like like a quadratic curve going up and down. Do you know what I'm saying? So it's like this, like this, like this, like this. Do you see how I'm doing that? So that's why I'm saying don't be too concerned about where this hits it on the curve. It's more about the shape. So this. You see what I'm saying? And a key about the asymptotes is you shouldn't be crossing the asymptotes. Okay, so the amplitude, what would the amplitude be here? Yeah, you can't really measure it. It's infinity. We'll put infinity, or we can say none, undefined. What's the period here? How long does it take before that cycle repeats each other? It's pi, yeah. What about the domain? Yeah, it's everything except where the asymptotes are. So maybe we should look at what the asymptotes are. The asymptotes are negative 3 pi over 2, negative pi over 2. What was that again? Yeah, so x equals 2k plus 1 pi over 2, where k is an element of the integers. So the domain then would be all real. The domain is way too hard to state the domain as a interval notation, so I'm going to do it as set notation. So set notation, of course, is x is an element of the reals. X cannot equal where the asymptotes are, which is 2k plus 1 pi over 2, where k is an element of the integers. Yeah, wow is right, hey? What about the range here? Yeah, it's everything, yeah. So I'll put it as set notation, negative infinity to positive infinity. Okay, how about the y-intercept? 0. What about the zeros? So look at the trend. 0, pi, 2 pi, 3 pi, 4 pi. What is that called? K pi. That's right. K pi, where K is an element of the integers. What do you think about that for the tan graph? Okay, so this is really cool. This is the graph of sine. So do you remember from grade 11, we learned how to sketch 1 over f of x. Do you remember that? The reciprocal function? Okay, so how would we do this? How would we graph the reciprocal function of this? Well, what did we learn in grade 11? That all the zeros became, if you reciprocate 0, what do you get? Undefined. So all the zeros became asymptotes. Yes? Okay, well that's too much information. Yeah. Okay, then what were the invariant points when we reciprocated stuff? 1 stayed as 1. So that means 1 here stays as 1. This one stays as 1. This one stays as 1. This one stays as 1. What happened to negative ones when you reciprocate it? They stay the same as well. Yes? Okay, now think about this for a second. If we are getting smaller in number and we reciprocate it, what happens? It gets bigger. What's the biggest it can get? Infinity, right? Goes to infinity. Smaller, we flip, gets infinity. It looks like a parabola, doesn't it? Does anybody know what I just graphed here?
The inverse.
Not the inverse. Inverse is not reciprocal.
Oh, right.
What's the reciprocal function of sine?
Oh. No, cosecant.
Cosecant. We just graphed y equals cosecant x. Isn't that cool? So, for fun, if you wanted to graph secant graph, you would start with a cosine graph and reciprocate that. Guess what it'll look like? Kind of like this, except shift it over. Oh my gosh. Guess what happens to the tan graph when you reciprocate it? It looks very similar, and if you want, you can graph it on your graphing calculator and you can see it. It gets shifted over, and the negative and the negative is still the same, but because the asymptotes switch a little, it gets a little bit. It still did the line thing? Oh. I'm sorry.